muted. So please let's mute ourselves. So for today, before we start today's session, concerning the assignment, you're going to get it today, but there will be a time that will be stretched for immediately after all the sessions. We're going to upload it. We're going to send all the assignment. We're going to send all the lessons to your mail. So you're going to have to watch again and be able to take the assignment if you weren't in yesterday's class. But welcome everyone. If there's something you learned yesterday that you can talk about, I would like to see it in the chat. So today, before we start our class proper, we'd like to just have a recap of what we discussed yesterday. And so yesterday, our facilitator, if you're not in class yesterday, it's fine. Our facilitator is coming on board today, and it's just going to, for yesterday, and it's just going to make just like a 5 minutes recap of what we talked about yesterday. So a round of applause as I welcome Mr. Sheon to just come and give a recap of what was discussed yesterday. So please, a round of applause in the comments. Let me see that you are here. Let me know you are here. So Mr. Sheon, over to you.
Good evening, everyone. Good evening. I'm sorry to begin, and just want to give that because I'm pretty sure there's some people that are presently that didn't attend yesterday, and it was really power packed. And also, yesterday was like the basics, because for you to understand today's one, you must have at least a little bit of knowledge of yesterday's class. Let me just give a quick overview about yesterday's class. So yesterday we talked about AI, like what really AI is, and we understood that there are two major types of intelligence. The first one is natural intelligence, which is the one that God gave us. Then human wanted to do something similar to what God gave us. Then that was where artificial intelligence came out from.
Hey,
Understand?
Mr. Sheon,
And
to cut you, I think your voice is echoing. It's bringing out some sound.
oh, really? Sorry. Let me try to adjust my. So is it still the same, or probably adjust? Is it still the same?
Better, though it's breaking at some point, but I think it's better.
Oh, yes. Come on, let's connect this. I'm coming. Can you still hear me? Or is it still breaking? I just want to know, actually.
I think it's clear right now.
It's still breaking, right? Okay. I'm so sorry. I don't know why it's like that tonight. Nigeria could happen sometimes. So I was talking about we have two types of intelligence. We have the natural intelligence and the artificial intelligence. Natural intelligence is the one that in animals. I'm probably humans, they are animals in this sense. I know a lot of people don't like to be called animals, but for simplicity's sake, let's just give it. So natural intelligence and we have artificial intelligence. Humans are trying to build something similar to what God created. So humans that the psychology, some of the working principles of humans, like for instance, human beings have eyes, and that was why we built something like computer vision machines. Computer vision is when your computer can see. An instance is face recognition system. Human beings noticed that they wanted machines to know how to speak and hear, and that's your natural language processing cousin. That's when your mind can speak, can hear, respond to you. Human beings also have we also have our brain, you understand? And what does our brain do? Our brain passes judgments, and that's why there's machine learning. So machine learning helps to predict, and when you're predicting something, that is like judgments, you understand? So that's like the basics. I just want you to understand that human beings are following some of the working principles of how God created us and applying it to machines. Then the last part is we can perform some locomotion by shaking our hands, by moving, you understand? So human beings wanted to be something similar, and they created robots. That's why robots can move, they can shake their hands, they can perform locomotion. So that's just like the brief of how they will do it a little bit more fuller than this, but we'll also send the slides. Yeah, I think that's all. Over to you, Victoria.
All right, thank you very much for the recap. I'm very sure that everyone or someone who wasn't hearing before will be able to, who wasn't here before, will be able to understand or at least catch a glimpse of what was discussed yesterday. So thank you very much for the brief insight. So tonight we have another session, and I'm happy to announce to you that this session is going to stretch. So get your water by your side, get your notepad by your side, and I promise you it's going to be a very, very amazing session, because the tutor yesterday, you felt like it was simple, that it was okay, you felt like it was simple, it was insightful. Today's one is going to be so amazing again. So I'd like to read the bio of our speaker for tonight. Please mute yourself. I wouldn't like to have some echoes during the or some other side talks while reading the bio. So for tonight, as I read his bio, please just be dropping your, I want to see your claps, I want to see the energy, I want to know that you are here. So he is a software developer, a C++ enthusiast, and a data engineer who has made a lot of significant collaborations in several regions across the globe, making a huge difference in the tech space. He holds a bachelor's degree in mechatronics engineering from the Federal University of Ekiti, an institution that creates a conducive and sustainable environment for technology to thrive. At BigPal, where they are all about providing solutions and dreaming big in the tech world, he is the co-founder and the software engineer. He is a creative and critical thinker who builds their software system and deploys the AI models for inference. He also works alongside with the AI engineer and the product designer, making sure everything runs smoothly. With his expertise in cloud computing, building secure backend systems, database management, deploying AI models, building a front-end system, Precious' main goal is to create seamless and secure systems, both software and hardware systems, that align with systematic development standards, as well as satisfying clients. Ladies and gentlemen, please a round of applause as I welcome Mr. Precious Aghulor. Mr. Precious, you have the floor.
Yeah, thank you so much, Victoria. Yeah, it's great to be here. Great to be here. All right, so let me begin. Okay, so just like Victoria said, the co-founder and the software developer at BigPal. So I'm basically core into C++ development. So I build enterprise systems, enterprise softwares, and I work on embedded systems as well, apart from web development and other software development I carry out. Okay, so today's class is going to be majorly on the applications of AI in software development. Okay, so sorry, let me share my screen. All right, so Victoria, please, my screen visible.
Yes.
All right, thank you very much. So let me just go through my name again. My name is Precious Aghulor, and I'm popularly known as General Ossi. Yeah, so I'll be your presenter for today, and today is going to cover applications of AI in software development. Okay, so before we begin, I want to familiarize myself with the audience. So I just want to ask a question. I want to throw out a question to everyone. So let's imagine a scenario, where where you have to undergo surgery, and you actually had two options on who was going to operate you. Okay, so now the first option is to pick a surgeon who has 85% success rates, and this surgeon has a lot of experiences in a career. And the second option is to pick an AI robot who has 94% accuracy in its model training. Now, this AI was actually trained on a lot of data, including the surgeon's data and other data of experts. So, who would you pick? You can drop your answers in the chat and also drop why you go with the option. All right, so actually, when I asked a friend this question, do you know what his response was? His response was actually that he's going to choose the two. So he said that he's going to choose the two so that they work collaboratively. All right, so let me begin with today's session. Okay, so we'll be going through several modules today. So we'll be looking at the introduction to AI in software development. We'll be looking at the applications of AI in software building. We'll also be covering building AI softwares, that's the basics and considerations. Then we'll be looking at AI startups and innovations in software. We'll also be covering the relevance of AI in software development, the benefits and drawbacks of AI in software development, and lastly, the future trends and implications. All right. So what is AI? AI is like a buzzword which most people use 90% of the time. You hear people saying AI, artificial intelligence, but the thing is, most people don't really know what AI is. But kudos to everyone who was in our class yesterday. So I'm sure most of us or everyone in the class yesterday was able to get an in-depth understanding on what artificial intelligence is. So I'll just like briefly go through it again. So AI refers to the development of computer systems that can perform tasks which require human intelligence. So what do I mean by this? Let me give a scenario. So let's consider a company that provides online services and products. Yeah. So now this company wants to actually enhance their customer support. So this company decides to implement an AI-powered virtual assistant to handle their customer inquiries and support requests. Yeah. So they contact an ML engineer to build a chatbot instead of making use of an human for the chat and support systems. Now, this task, yeah, is a task that requires human intelligence, which is building a system that can carry out this task. Yeah. So building a system that can carry out this task actually is just building an AI essentially. So that's just what AI does. That's what AI is. Okay. So let's go to the next slide. The subsets of AI. So like my colleague already explained, so we have several subsets of AI. We have machine learning, we have NLP, natural language processing, we have computer vision, we have robotics. So machine learning is a subset of AI which focuses on developing algorithms that enable systems to learn from data to improve their performance over time. So we actually have different types of machine learning. So we have the supervised learning and unsupervised learning. So like the name implies, supervised learning. So this supervised learning is just more like training your AI model under supervision. That is giving it data which has labels. So while unsupervised learning is a kind of machine learning which involves training your AI model without labeled data. That's making use of unlabeled data. So you just give it the data, then you allow the machine learning model to actually draw out patterns, then cluster each of those data, then label it by itself. Then we also have natural language processing. So natural language processing involves making systems which help computers to understand human language. Yeah. Then we also have computer vision, that's making or enabling your computer see. Then we have robotics. So let's look at the historical context and key milestone in the convergence of AI and software development. So I'll be taking AI, artificial intelligence separately, and I'll take in software development separately. So let's look at the historical content for both. So for the history and milestones of AI, so we have rule-based systems. So what are rule-based systems? So a rule-based system is often referred to as a one-task system. So these are systems which operate on specific based rules. You can call them systems that think inside a box. So they are limited to their rules. There's rules which they are being built upon. So now these systems cannot think or make decisions outside these rules. So it's just like it's just limited to the rules which you train it on. Then we also have context awareness and retention systems. So now this kind of systems, like name implies, context awareness and retention systems. So they are able to remember previous interactions and make use of these previous interactions to make future predictions and recommendations for you. So now this part of AI takes a leap from the rule-based AI systems. So an example of this kind of systems is we have ChatGPT. So you'll notice that whenever you're chatting with ChatGPT and you give it a prompt, you notice that, okay, after giving the first prompt, if you want to ask or give it another prompt, you notice that it will use your previous chat, that's the history from your previous conversations with it, to give you answers or recommendations. So ChatGPT is a good example of these kinds of systems. Then we also have the domain-specific mastery systems. Like name implies, domain-specific. So this kind of AI systems are systems which are built specifically for a particular field. For instance, let me use law now. Okay. So for instance, you want to build an AI system that understands law, like knows everything and anything about law. So you build it as a domain-specific system. So it only knows everything about that domain. For instance, now we're using law. So if you are building a domain-specific AI model, so it only understands everything under law. And if you're asking it about maybe if you're asking it about languages or you're asking it about anything outside law, it won't be able to give you any reasonable answer because it is domain specific. So these kind of models are not generalists. They're actually specialists. So they are specialized in their particular field. So I don't know if we know DeepMind AlphaGo. So DeepMind AlphaGo was actually built to master a board game called Go. So it actually identifies patterns and analyzes data. So if you can actually like go online to make research on the AI model, DeepMind AlphaGo. Yeah. So they built it on the domain of the board game Go. So it doesn't know anything apart from Go. Yeah. Then we also have thinking and reasoning AI systems. So this kind of AI systems actually mimic human thinking. So this is where deep learning and reinforcement learning comes in. So now here, AI makes its decisions based on its experiences, that experiences it has had. Yeah. So these are how systems you build using thinking and reasoning systems work. Then we also have artificial general intelligence. Okay, so now artificial general intelligence is, some people say, okay, we have gotten to the age of artificial general intelligence, but I would say we've not gotten to that stage yet, but we are close to that stage. So this stage is actually the ability of AI models to understand, to be able to learn, to be able to adapt, and to be able to implement knowledge across a wide area of tasks. So artificial general intelligence can actually perform any task that a human can perform. So now, when we get to this stage of AI will actually be able to possess self-awareness, they'll be able to possess empathy, they'll be able to possess conscience. But we've not gotten to that stage yet. At least some people might say when we get to this stage, AI will be scary, AI might be a threat and all. So we also have artificial superintelligence. So artificial superintelligence now, it poses cognitive skills that surpasses the human skills. Yeah. So this stage now is higher than the artificial general intelligence. So at this point, artificial intelligence will actually be better and more intelligent than humans. So at this stage here, we can say that AI will be a threat to humans because AI will be able to think better and make better decisions than humans. Then we have the last milestone, which is AI singularity. So now this milestone is actually a hypothetical future point in time. This is when technology will actually advance and become uncontrollable and irreversible. So here it will become like a big threat to the whole universe entirely. Like it will become a big threat. Here, AI will start creating AI, and they can turn to something else that we don't even understand in the long run. So this is like the peak of AI. So this is just like an hypothesis. Some people say we might reach this stage. Some people say we might not reach this stage. But let's watch out and see because technology is actually advancing. So let's see how it goes. So this is a chart showing how AI is increasing and human intelligence increases too. So when we get to the point whereby artificial intelligence crosses or surpasses human intelligence, that's when AI singularity comes in. And once we get to that point, AI's 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 revolution will become very rapid. Like it will increase over a very short period of time. Because at that point, we would have AI making critical decisions and you have AI building AI systems. So, but generally, we just have three stages of AI. So we have the artificial narrow intelligence. We can call this we can call this kind of intelligence the rule-based intelligence, whereby they are just like programmed on a set of rules. So they just think within a box. So they can just perform like one specific kind of tasks. They also have the artificial general intelligence and the artificial super intelligence. So let's look at the history and milestone of software development. Hope we are following the class. Okay. All right. So the history and milestone of software development, I would like to categorize them in different stages. So let's start with software 1.0. All right. So software 1.0 is actually human driven. At this point in time, software was actually human driven. It was rule based. It was it had limited efficiency. So at this point in time, we're actually like building softwares, making use of just basic if and else statements. For instance, if you want to sorry, for instance, if you want to build a software that's maybe a software that is used to predict, or sorry, a software that is used to like give customers prices of a house. Yeah, let me use the example. A software that is used to give customers prices of a house. For instance, if I want to build this kind of software at the time of software 1.0, would have to write lot of if and else statements, nested if and else statements, making use of different prices. So we can say, or sorry, making use of different conditions. So we can say if the house has a light, if the house has a backyard, if the house has this, the price should be this. If the house has this, if the house has that. So those were the kind of systems which were being built at that stage. So now this kind of systems were actually limited because, I mean, you can't write 1 million lines of code because you just want to build a software in a single script. So it was actually limited. So you could just like base this kind of systems on a limited performance, and they were rule based, and they're actually human driven as well. Then we also have software 2.0. So at this point in time, we've not gotten to software 2.0. So when we get to software 2.0, we'll be able to make use of AI to create and build softwares. So at this stage, we would have AI programs or AI systems that can build softwares for us top down. So at this point in time, we won't need to stress ourselves. We just write a prompt for the AI and to build these systems for us. Give us the complete code, help us create our code base, deploy our model for us, and carry out every other thing. So at this point in time, efficiency will be very high. So currently, we're actually in between software 1.0 and software 2.0. So we are in between, whereby, okay, we are making use of AI as an assistant to help us in coding, but we are still writing the codes ourselves. Then I would like to also cover software 0.0. Okay, so this stage, some people call it our forefathers, that's our daddies and mommies era, or it might even be before our daddy and mommy's era. So at this stage, everything was manual at this stage. Everything was totally manual. For instance, if you wanted to maybe go to a bank and collect a loan, so you would go to the bank, you meet the cashier or the attendant, then he would have to collect, okay, your details, write it down, then you tell him the amount you want to collect. So now, telling him the amount you want to collect, you have to carry out a calculator and start calculating values to calculate their interest rates, returns, and every other thing. And it was really stressful and it was time consuming, and it required a lot of human personnel for it. So let's look at the examples of AI integration in real world software projects. So we have the likes of ChatGPT, we have the likes of Midjourney, we have Google Bard, Copilot, that's GitHub Copilot. We also have Synthesia. We have Adobe Fireflies. Those ones, our designers know about that. Then we have BigPal. So let's look at the applications of AI in software building. Now, if you want to, there are different ways to apply AI in software building. So we can go from the development stage to the quality assurance stage to the deployment stage and to the maintenance stage. So I'll just be briefly going through all of them one by one. So for the development stage, that's where you have the developers, software developers here. So we have AI that can help us in. Okay, so we have likes of Copilot, AI that can help. Yeah, sorry for that. So we have the likes of GitHub Copilot who can help us in coding, like writing codes. For instance, how GitHub Copilot works is, let's say you are trying to type or write a code, it can help you auto-complete that code, or it can help you generate like a code snippet. Then you have to like complete it. Then there was a new version of GitHub Copilot that just came out, and there are a lot of hypes about it. It's called GitHub Copilot X. So it's more like for people using VS Code, you can integrate it into your VS Code, GitHub Copilot X. So it's more like integrating GPT-4, or let's call it ChatGPT, into your terminal or into your VS Code. So instead of making use of tools like ChatGPT, Bard, copying and pasting into your IDE, you can just integrate GitHub Copilot X directly, and it will be writing the codes for you in real time, and you'll be able to test it. Then we also have AI models that can help us with comment generation and login generation. So, for instance, you're writing codes. Codes are actually meant to be well commented, because if you're working on a very large code base, you need to comment your codes so that other developers will be able to understand what you're doing. Let me not go too deep into that. So we also have the quality assurance. So for the quality assurance, what do I mean by that? The testing planning, optimizing testing, then the security and regulation, and sorts like that. Then we also have, you can also apply AI in the deployment stage. Talking about deployment, we have the CI/CD aspect. That's continuous integration and continuous development. And we can also use AI for maintenance. That's predictive corrective maintenance and tech debt reduction. So yeah, one thing to note is that whenever you're using AI to work, always ensure that, okay, let me leave that to the ending part. So let's continue. Okay, so the next module is going to be building AI software. Look at the basics and considerations. So if you want to build an AI software, the first and foremost thing you need to do is understand AI, like have a general understanding of AI. You need to know the different languages we use in writing AI. So we can use Python, we can use R to write AI code. So you need to even understand AI, you need to understand the kinds of models we have. The kinds of models we have, the types of AI, subsets, and all. Just have the general understanding of AI. First things first. Then afterwards, the next step is to get a machine learning engineer. To get a machine learning engineer to build your desired AI model, or you can make use of existing APIs. So I actually prefer to make use of sometimes I prefer to make use of existing APIs because it makes work faster. For instance, if you are working for a client, it will be best if you use an existing API. Or if you can contract it out to an ML engineer, that works too. So let me talk about APIs. I'm very sure most of us might not know the meaning of API. So API is called Application Programming Interface. So look at this image now. Let's make use of a restaurant now. Let's use the analogy of a restaurant. So if you look at this picture, you see the waiter at the center. So we can say the waiter is the API here. So we have the kitchen and we have the customer. So the waiter is in between the customers and the server. So the waiter is just like a link between, or it's like, let me use word interface. It's like an interface between the kitchen and the customer. So the waiter goes to the customer, asks the customer what he wants, or the customer can meet the waiter and tell the waiter what he wants. Then now the waiter collects his requests and takes it to the kitchen to meet the chef. So he waits for the chef to actually cook up what the customer wants. So once the chef is done cooking up, he would give it back to the waiter, and the waiter would now give it back to the customer. So that is how an API works. So the front-end part of the system, that is the user interface where users interact with the system, they'll make requests to the API. Then the API goes to the server, the backend server, contacts the cloud service, database, then gets what the user wants and returns it back to the user. So that's how an API works. So, this image is very descriptive. So after that, you'd reach out to the ML engineer. So, we're talking about building an AI software. So what are the things we need to consider? So the first thing was to understand AI, get like a general understanding of AI, know how to make use of AI, the frameworks you make use of, the languages. Then you'd get an ML engineer, or you'd make use of existing APIs. And I've explained what APIs are. The next step now is if you made use of an ML engineer, you would have to reach out to that ML engineer to make research on the data processing steps he carried out on the model and ask him other questions. For instance, you can ask him questions like, what are the functions I'll be making use of so that this AI model can actually work seamlessly at my backend? What are the libraries I need to work with? How will the data preprocessing be? Because how AI models work, AI works with data. Like AI's life is data. Without data, you can't have AI. So if after training your AI model, you deploy it to your system, that's your backend system, for this AI model to work now, you need to give it data. Then based on that data you feed it, it will make predictions for you and give it back to the user. But now this data, you cannot just give the AI model directly like that. You have to actually carry this data through the same data preprocessing steps that were used to build the AI model so that you won't have any issues with the AI model. So you need to ask the ML engineer for those steps and Okay, whether you're using a data pipeline or if you just be using basic data preprocessing steps, making use of NLP to just claim your data. So let me briefly explain what functions are because I made mention of functions here. All right. So a function is just a code that helps you make up something that gives you a result at the end. So for a function to work, you need to give it some things. So those things we call them arguments, right? Or you can call them parameters. Yeah. So let's take this function as an example. Make sandwich. All right. So you want to make a sandwich. You know that to make a sandwich, there are actually like basic things you need to make this sandwich. You need to get your bread. You need your ham or meat. You need your veggies. You need butter, bama, depending on your taste. So you take all these parameters and give the function. Then now what this function does is it carries out the process to make the sandwich inside it, and it returns the finished sandwich. So functions are just like codes, or I can call them containers that help you simplify or make that help you make a particular operation simplified. Yeah, let me use that approach. So functions are containers that help you make a particular operation simplified. So for instance, now you can carry, let's say functions were actually realistic. So you can just create a function in your house called make sandwich and you keep it somewhere, maybe in your cupboard. Then when you want to make sandwich, you just call the function, you give it bread, you give it your veggies, you give it ham, and it will return your it will return your sandwich for you, your very prepared sandwich for you. You can also, okay, let me use a real life example. We have like coffee mixers, we have toasters, pots, you can call them functions. So their function is actually to, if it's a toaster, its function is to toast bread, to make your bread toast, and so on and so forth. So you give it your bread, it carries out the function, the operation inside, which is to toast your bread. Then when you open it, you collect your readily made toasted bread or toast bread. Yeah, so that is how functions work, or that's what a function is. So now, after reaching out to the machine learning engineer to get research on what you'll be needing to make the AI model run seamlessly at your backend, the next step will be to deploy and integrate this AI model into your software. So now for this, we have different types of deployments. So we have the cloud-based deployment, we have the on-premise deployment, we have the edge deployment, and we have serverless deployment. So what most people use often is cloud deployments actually. But let me just briefly go through other types of development which I mentioned. So I made mention of on-premise deployment. So this kind of deployment just involves hosting your AI model. So first of all, let me even say what deployment is. So deploying AI models means to integrate it into your software. That is after you've gotten the built AI model from the ML engineer or the API, the existing API, you'd actually need to add it at your backend. So you just put it in the required place it needs to be. For instance, now, like the waiter, in a restaurant, the waiter is meant to be maybe at the counter or is meant to be within the guests in the open room so that, okay, yes, you can easily interact with it. So now you need to put your AI model or the API you want to make use of in the required place or position it's meant to be in your backend. So I'm trying to make it as simple as possible. So now to making use of on-premise deployment is carrying your AI model now and putting it in physical servers. So what are servers? Servers are actually systems that help your softwares run. So you can put you make use of servers to run your softwares. So now on-premise deployment is just hosting your AI model on physical devices. But due to complexity of these kinds of deployments, it's actually hard to maintain when it comes to cost because you have to maintain the cost of cooling the systems and other things. Then we also have edge deployment. So edge deployments involves deploying your AI models on mobile phones or making use of edge devices. Then we also have the last one we have is serverless deployment. So this serverless deployment now is making use of containerization. Let me not go too deep into it. Let me come back to cloud computing. That's making use of the cloud to deploy your AI models. So now, making use of the cloud system is just about hosting your AI model on a virtual network or service, which is being maintained by a third-party company. For instance, we have different cloud services like AWS, we have Google Cloud, we have Microsoft Azure, and so on and so forth. So now for this kind of case, we make use of VMs, virtual systems or virtual machines, to actually host our AI models. So yeah, this is just like a tutorial view of how cloud computing works. So at the center here, we have the cloud. Then the cloud communicates with different things. So the cloud is just at the center point. So we have the storage, mobile, we have applications, we have database, and we have the server. So all these now communicate with cloud to get a form of data or anything like that. So for instance, now let's assume our AI model was inside the cloud. So now if an application wants to make a call to an AI model now to make a prediction or to make a forecast, it would come into this cloud, communicate with that AI model inside the cloud, and the AI model will give it back its response. But now this cloud is actually on a virtual machine. Yeah. So we also have different kinds of cloud. We have private cloud, public cloud, and hybrid cloud. But I don't want to go in depth into that. So the remaining steps we have is testing and validating the system. That's after deploying your system. Then you carry out continuous improvements. Then you also carry out documentation. Yeah, so when building software, documentation is very important because on the long run, you need to fall back to those documentations. For instance, now building BigPal, it's my colleagues in my team. I mean, documentation has really helped us like so far because I am the software developer. We have the AI engineer. We have the database guy, and we also have the systems guy. So doing all this now, we need documentations. For instance, if I want to make reference to how the AI model was built or the criteria I need to make use of the AI model, I need to fall back to that documentation instead of always disturbing the AI engineer for feedback and responses because he will definitely be busy doing other things. So documentation goes a long way. Then we also have ethical consideration and responsible AI deployment. Development. Yeah. So when building AI softwares, you need to take into consideration ethics. So what do I mean by ethics? Like when you're building AI softwares, you need to ensure that it doesn't go outside the general ethics. Like it doesn't affect the lives of people making use of it. For instance, if if you are building a software that actually detects COVID, but thank God we're past that COVID era. But if you're trying to develop a system that helps predict COVID, and after the system predicts the COVID, probably the kind of system now you're building is the kind of system that will display the results with the user's name. So that kind of thing. Now, if another user wants to make use of that software, we'll see all the people that had COVID or something like that. So that actually goes beyond the ethics, like general public ethics. So anytime you're building any software in general, you always need to consider specific ethics. And you also need to ensure that the software follows like privacy and security measures because consumers and users are very paramount when it comes to their privacy. So now we'll be looking at AI startups and innovations in software development. Yeah. So AI startups, right? So now if you want to build an AI startup, so there are different stages you need to go through. So the birth of an AI startup, yeah, is actually ideas. So you need to come up with an idea first of all. You need to think of an idea. So actually, ideas are cheap and easy, but implementing and realizing those ideas is the main thing, because anybody can come up with any idea and implementing this idea now. When it comes to implementing this idea now, or actually making this idea come to reality, that is when the problem will come out, because some people might bring up like unrealistic ideas, things that are not possible. You just come up with it, and yeah, that will affect realizing those ideas. So yeah, you first need to come up with the ideas, then you need to consider the fact that it's not just about coming up with these ideas. I also need to ensure that these ideas I'm coming up with are actually implementable and realistic. Then, coming up with these ideas too, you need to ensure that you're solving a problem. Because if you come up with an idea and you want to actually develop a system to solve this, like to carry out this idea you came up with, you need to ensure that, okay, it's actually solving a problem. You need to ask yourself, okay, am I solving a problem with this? Because if you're not solving a problem, yeah, trust me, nobody will use your software. It will just be there. Yes, you create a good software, people will be like, yes, I like your software, it's doing great, but nobody wants to use your software because it's not solving any problem. Yeah, you should not build a software and people will be like, hey, yes, I use your software, but like it's not adding any impact to me. It's just the yeah, it's cool. But it would be nice to hear people that, hey, thank you so much. I really love your software. It's solving a lot of problems for me. This, and this were made very easy for me. For instance, look at ChatGPT. It's solving a lot of problems, like making life easier for a lot of people. And we also have other AI systems. Then we also have BigPal too. BigPal is actually solving the problems for students and for readers. But I won't go too deep into that. Then the next thing now is to know your target market. So you need to actually, this is a very critical step when coming up with a startup. You need to know your target market, because if you don't know your target market, you just, yes, you're solving a problem, you build the software or you build the product. You don't know your target market, so you won't know the people to advertise to or the people to actually go to meet, like channel your product to meet. You won't know the kind of people to tailor your product to. So your product will just be there. Even if yeah, they are the people that need it, they won't have access to it because you don't know they need it. So you won't be able to push it or tailor it to them to make them know that okay, yes, this product was made for you. Then another thing is don't build a feature, build a niche. So what do I mean by this? When you want to build a software, don't build a feature like, okay, yes, this thing is just helping me maybe clean a text, or this product is just helping me blur pictures. I mean, that's just a feature. That's just a feature. You need to build a niche, like find a problem and build a software or product that is actually solving everything in that problem. At least, if not everything, more than 50% of that problem. Like it's solving um more than 50% of that problem. You should not just be solving like 1% or 2% of that problem. So don't just build a feature, but build a niche. Then another thing is you also need to build from scratch. I mean, this is actually the recommended way to go. Yeah, most people make use of existing APIs, they make use of existing code base, and they make use of different plugins, templates, and sorts like that. But now, if you are making use of all these systems and you're actually like, okay, yes, you build your product, you're actually like thriving in the tech space. If the owners of these frameworks or the owners of these templates you are using actually shuts down tomorrow, I mean, the software will become obsolete. Like it won't be able to function again. So the best way to go would actually be to build from scratch so that you know the in-depth and every detail of your software. You know how your software was built. So if you want to change anything, if you want to manipulate anything, if you want to change the direction of the software, you would always be able to do that at ease. So it's always recommended to build from scratch. Then you keep on improving it. So softwares are all about improving. You can never stop building the software. till date, I can tell you that Google is still improving their Gmail service. They're still improving YouTube. They're still improving their web service, that's their web search service. Like they keep on improving it every day. Because I mean, nobody wants to lag. Nobody wants to lag behind. Everybody wants to keep up to date. So software building or software development is a continuous process. Just need to keep on improving it. Then you also need to leverage on the limitations of AI. All right, so this is like an aspect whereby people don't really know about, but to actually make like a good software, you also need to leverage on the limitations of AI. So what do I mean by this? Look at when you're building a model, look at the limitations of this model. Don't just assume that okay, yes, this model can do everything or it can do anything. Yeah. So you need to look at the limitations and see how you can maybe um solve that limitation. Maybe okay, building a different AI model to solve that, or making use of another system or a rule-based system or an algorithm to solve that limitation. So you should not just like base everything on the AI because definitely AI has limitations. For example, if you are building a software that's which example can I use? Okay, if you are building a software that converts documents, so let's say you are using an AI algorithm, or sorry, an AI model that actually converts PDFs, only PDFs. So you notice that okay, yes, this my model is can only convert PDFs to any other thing. Yeah. So now if you just leave that your model and your software like that, okay, yes, it can only convert PDFs. I mean, it won't really fly. So you need to look at the limitations. Okay, this model cannot convert documents, that's docs file, it cannot convert TXT. So you need to try and leverage on those limitations and maybe build other models or have like backups for those limitations so that you still be able to thrive. Then you also need to keep updated with the trend. Always follow the trend. If people are going left tomorrow, you need to follow them and go left. If they are going right, you need to follow them and go right because you always need to keep yourself updated with the trend. Then lastly, you need to also get funding. I mean, it's very important with startups. Yeah. So yeah, I would also recommend for people who would like to maybe create their startups or know more about startups, I would recommend the movie called Silicon Valley. So it's actually an interesting movie. Yeah, it's a must watch for developers or programmers. It's very interesting and motivating. So I would encourage you guys to watch it. So now let's look at the benefits and drawbacks of AI in software development. So there are numerous benefits and numerous drawbacks of AI in software development. So let's look at the benefits first. So for the benefits, we have AI helps us in the automation of repetitive tasks. For example, talking about software 0.0, whereby you have to go to the bank and you meet the cashier, you have to give the cashier your details, then you have to carry out those steps, put in your details, press the calculator to come up with different values for you before now approving the loan. I mean, that might take up to a week or a month sef, if you actually want to go through every details. But with the use of AI, it automates those kinds of repetitive tasks and it will increase efficiency. So it also helps in improve decision making, helps us make better decisions. Then it also gives enhanced user experience. It also helps in predictive analytics and insights, optimization and efficiency. It helps in optimization and makes the whole system efficient. Then it also helps in continuous learning and adaptation. For instance, if you have a system that needs or works on data, probably it needs data to make predictions or forecasts. Like it needs to predict it needs to make weather forecast to know what the weather will be tomorrow. So AI models or AI systems help in that. So you just feed it your data and it keeps on learning on those data. For instance, now if rain falls today, probably the temperature was cold, we had a particular kind of humidity, and rain falls today. Okay, maybe that same thing happens tomorrow and rain doesn't fall. Now you feed your AI model this data and it will learn continuously on it. To be able to find patterns from that, and it will adapt as time goes on. So it will be able to help you make better forecasts along the line. Then it also helps with natural language interfaces, then advanced data processing. So we also have numerous drawbacks. We have the lack of transparency. We have data bias and quality. So when it comes to AI, so if you don't train your AI with good data, your AI is going to be biased. All right. For instance, now uh, you want to create a machine translation model. Yeah, you want to create a machine translation model, and you just give that your AI model, that's your machine translation model. You just give it English data. You give it maybe German data. You give it French data. I mean, after giving it those sets of data, yes, their languages, but you give it those set of data. If you are trying to maybe give it Yoruba to help you translate, I mean, it will be predicting rubbish. It will actually translate it for you, but it will be translating rubbish. It might actually give you the translation in German, but it will mix French and German for you together. So data bias is also another drawback of AI. Let me use another example. For instance, you are creating a recommendation system for females, and creating this recommendation system for females, probably as a male, you want to use that kind of system.
That big girl no go
That system, that kind of system will
that
actually
big
be
girl
giving
no
you,
go.
yeah, sorry for that. That kind of system will actually be giving you bad results because the data you gave it was biased. So if you actually want that model to perform well, actually need to give it. Okay, so let me come up with that scenario again because of the interruption. So now I was making use of building a system that makes predictions. So if you want to make a sorry that makes recommendations, yeah. So if you want to build a software system that would make recommendations for users, like okay, if your target market now is all users, and you're now feeding that your model with more female data, and you're giving it just few data that are for male and few data for children. If you are trying to make predictions for men on later on, it will actually be giving you a bad result because the data you gave it was biased. So it had more of females, less of males, and less of children. So if you actually want to like make a robust and a good system, you need to ensure that the data you're feeding your AI model is not biased. Then talking about data quality, like data quality goes a very, very long way. For instance, if you're building a model and you feed it with 1 million data, like, okay, let's say you're trying to build a translation system and you feed it with 1 million lines of data, like 1 million lines of data. But now this data you're feeding it is actually bad. It's not cleaned properly. There will be a problem for the AI model. There will be a big problem. So when you're trying to translate, the AI will actually be giving you bad results. But now, if you are very paramount on data quality and you are feeding this your model, even let's say 50,000 or 100,000, trust me, the data you gave it, the model that you trained on maybe 100,000 sentences with a very clean data and will do better than the model you trained on 1 million data because of data quality. So it goes a long way. Then you also have ethical concerns. Then we have limited generalizations. We have security risks. So a lot of people are like very disturbed when it comes to security and AI. So some people might say AI might take over the world. AI would make people lose their jobs. AI would this. AI would do that. Then we also have the complexity and skill requirements. That to build AI models, we actually need like skilled AI engineers or machine learning engineers. So it requires in-depth skill and in-depth knowledge. So you need to understand statistics. You need to know how the human body works because AI mimics humans. You need to be able to like make use of different frameworks and languages and stuff like that. Then we also have cost of implementation. Working with AI models is actually very expensive. Like it's very, very expensive. Then dependency on data quality, we've talked on that. Regulatory compliance, yeah. sometimes AI models don't follow regulatory compliances because different countries might come up with various regulatory compliance that, okay, yes, you should not have systems that do this, you should not have systems that do that. But I mean, you are building AI. AI does not understand that. So it will definitely be breaking those regulatory compliances. They also have job displacement concerns. All right. So what are the future trends and implications? So what I would say is AI will actually keep on advancing as technology advances, like that is on period. And you actually need to keep up to trends so that you won't be left behind. Like my colleague here, Alagbe, he reads research papers a lot. Like if you ask him what are you doing, he's reading research papers of new algorithms that are coming out, new systems, getting to know about how they build latest systems, LLMs and stuff like that. So you always need to keep on being updated with the trend. So if a new software comes out or a new framework comes out, I mean, dive into it, know about it, know how the system works. Don't be left behind. Because if you're actually left behind, I mean, it will actually cause a lot of implications. So, what are the must have AI skills? So, there are some must have AI skills I would recommend for people because I would say you don't need to be like, you don't need to be a programmer. Yeah, you don't need to be a programmer to actually have AI skills. Yeah, you don't need to be a programmer to have AI skills. So there are actually a lot of AI skills you can do without being a programmer. So the first skill is actually prompt engineering. So I mean, if you check online, you'd see that prompt engineers have been coming up recently, and trust me, prompt engineers are actually they're highly paid. Yeah, they're highly paid because prompt engineering goes a long way. So, for instance, we have different AI softwares that makes use of prompts. So, what is prompt? Prompt is like something you tell an AI system for it to give you a result. For instance, you tell the AI system, "I want this," or "Make me a coffee." So, "Make me a coffee." Now, telling the AI system, "Make me a coffee." That's actually a prompt. So, you are prompting it with those requests to give you an answer or feedback. So prompt engineering. Then we also have AI powered personal branding. So now you need to know how to make use of AI to actually carry out personal branding. So you can use AI to tailor your CV to become top notch. You can use it to rephrase your bio. If you are a developer or you are a solo, maybe you are a solo guy, yeah, maybe you're a freelancing guy, yeah, you can make use of AI to personalize your branding, get a logo. You can make use of Mid Journey to design a logo or Adobe Firefly. So there are different AI tools you can make use of to do that. AI powered branding, personal branding. Then we also have data storytelling and visualization. So now, like I said earlier, data is actually AI. Like data is AI. But apart from that, I mean, we use data in our everyday life. Like we use data, we interact with data. What I'm doing now is I'm passing across data. We've been online we've been online all gathered here. We're actually generating data, yeah, which can be used in one form or the other. So 80% of the data we have, yeah, in the world is actually unstructured. Like you just have random numbers in companies. Probably you're trying to do statistics. You have random numbers, maybe in the finance sector, you just be seeing different numbers. So now making use of AI for data storing and for data storytelling and visualization actually helps us transform mere numbers to a very understandable visualization and detailed storytelling. So I'll give an example now. For instance, let's say as a project or project manager, you're in a company and you want to give feedback to your boss or you want to give feedback to the team members on how the company has been going so far. So yes, you carry the performance, you carry the statistical values, you carry all the figures, the boring numbers and all. And you need to actually present all this to them. But now you cannot come and start telling them all those boring figures and all. I mean, they might not even understand what you're saying because they are not like in that domain, so they won't understand what you're saying. But now, if you use AI to actually help in data storytelling and visualization, you'll be able to explain all those numbers, what those numbers mean, using storytelling. Be able to explain it to them that, okay, at this point, this was actually happening. Or at this point, the company was doing well. Then at this point, they were not doing well because of this. So all those numbers the AI would help you transform those numbers into beautiful visualizations, which will help pass across the information. Then we also have creative AI thinking. So actually, AI is reshaping our world in different ways. For instance, now we have different artists making use of AI to create art. Like I mentioned earlier, we have Midjourney, we have Adobe Firefly. Yeah, we have a lot. We have a lot of different AI systems. I think, yeah, those are the ones I can remember for now. Yeah, so if you're an artist, you can make use of those AI softwares, create arts, yeah, use good prompts to create something wonderful and powerful. Then we also have cases whereby musicians make use of AI to create music. Yeah. So actually, yeah, sorry for that. So actually, yeah, the most like the most advancing area of AI so far has been the generative part of AI. That's making use of GANs, generative adversarial networks. So we have different kinds of GANs. I don't go into that. But the generative AI has been like the major niche of AI which people have been leveraging on. So look at the likes of ChatGPT. ChatGPT is a generative AI. Look at the likes of the Midjourney, the generative AI. GitHub Copilot is a generative AI. BART is a generative AI. We also have Synthesia. I don't know if you guys know about that. It's also a generative AI. So most AI softwares or systems we have, they are mostly generative AI. Then we also have AI business strategy and implementation. So now you can make use of AI to actually help you identify potential risk and create realistic roadmaps. Then we also have AI project management. That's you need for project management. You actually need something or some. You actually need someone, or you need a system which has a blend of technical and non-technical skills, because the person has to understand how the technical aspect of the company works and non-technical part works and actually manage the two parts. So you can actually make use of AI to simplify this for you. They also have NLP, that's likes of machine translation. So then we have curiosity and continuous learning. So let me go back to this NLP. What I actually meant by NLP, so that you guys will not like be confused here, is NLP is natural language processing, yeah, helping computers or machines to actually understand human language. So now you can leverage on this by giving your AI some particular prompts. For instance, okay, let me explain like this. For instance, you have a product and you actually know your target audience. Yes, you've identified your target audience. So now to tailor this your software to your target audience, probably this your software is a website or a mobile app. You actually need to like create content, maybe text content or visuals that will attract customers or users. So you can make use of AI to generate this tailored content or visuals. So you just give the AI a prompt and tell it, okay, I want to make a software for this, and generates interesting content that will actually attract my target audience and help you generate something very beautiful. Yeah, so that's what I meant by NLP. Then we also have curiosity and continuous learning. So this means just keeping updated with the current trends. So for instance, if a new software comes out or a new AI model comes out, I mean, dive into it, get to know how it works, know the in and out of it. So it's also a skill actually. Knowing or keeping updated with AI trends actually a skill. Then we have the intuitive understanding of AI limitations. That is, knowing when AI can be effective and when AI will not be effective to actually prevent biases. So now, without doubt, at this current stage, there are actually some things that we know that AI cannot do. Yeah, we know that there are some things AI cannot do. For instance, now, they've not really made AI systems that can generate content which are human friendly. What do I mean by that? Like AI content that you'd never even know that, okay, yes, this content was actually generated by AI. You read it as if, okay, it was an human that generated this. So in cases like that, okay, you should not use AI to generate the whole content for you. You can actually tell it, okay, to give you a snippet, then you modify it, or it should help you with different parts, or it should give you like an idea of how you go about it, so that you would actually not, it will actually not give you like a bad result. All right, so if there's anything you're going to take home from this class, it should be that AI will not replace humans. It's the humans making use of AI that would actually replace humans. And please know that AI cannot replace humans. They are our assistants. Probably when we get to the AGI milestone of AI or ASI milestone of AI, that's where we can start being scared of AI taking over humans or replacing humans. But now I would say AI is even creating more jobs than it's like displacing jobs. For instance, like I said, data is what AI needs. Data is what AI feeds on. So you can go into the aspect of data engineering, focus on data engineering. I mean, the aspect of data engineering, AI cannot take that part because if AI is actually being trained on AI generated content, it will get to a point whereby that AI will start diminishing. I mean, it will start generating rubbish. For instance, let's say an AI generated a particular text and the text was not accurate. And based on that text it generated, you fed it back to another AI model. Then that AI model now generated another text. So the result will keep on diminishing, diminishing until you just start saying rubbish. You start saying rubbish. So you can go into data engineering because the best kind of data fed to AI models are the kind of data created by humans. Then we also have prompt engineering. So we have a lot of prompt engineers. You can look into that. Um, there are different job opportunities AI is creating, different job opportunities. We also have data creators, people who help create data. Like your everyday life is data, so you can just randomly create data, do web scraping and stuff like that. Write content, like type, that's data creation. So there are different opportunities actually. There are also some other I didn't mention. All right, thank you.
Thank you so very much. That was a lot to unpack. Wow. I didn't know that yeah, I can be this particular to this session. Thank you so much. That was amazing. Please, if you listen very well in this session, just have a comment. I really want to see your comment. Like, how has the session been for you? How has it been? I want you to go explicit if you have to go explicit because these kinds of topics are most times, when it was mentioned, there's some terminologies it was mentioned that might sound so complex because it sounds like um they are